V3 న్యూస్ లక్ష్యం సమాజ హితం.
Good afternoon, dear students. Myself, Muhammad Asif. I've been teaching physics from last 18 years. And from today onwards, in association with the V3 channel, we are going for the discussion of small tips and tricks for the JEE mains and as well as of your NEET examination of 2020. I'll be trying to see, most probably trying to see that we'll try to do only such type of concepts where a difficult topic to be done in a very easiest way, shortcuts and tips and as well as of your methods. So for the today's session of a class, we'll be trying to discuss the relative velocity concept, that how to do the problems related to your rain and umbrella problem particulation, and in the same way river and boat problems in the easiest way. So let us try to come for the first concept what we are going to discuss. That one is your concept of rain and umbrella problem. Rain and umbrella problems. Concept of your rain and umbrella problems. I will be trying to do all the problems, all the critical problems of this one by one single concept, that as you know that in the relative velocity, when we talk about velocity of A with respect to B, velocity of A with respect to B, so this will be equal to velocity of your A minus velocity of your B. Relative velocity of A with respect to B is VA minus of your VB. That means here B is your reference. So who is seeing right now? Relative velocity of A with respect to your B. Relative velocity of A with respect to B. In the same way, when I am talking about your rain and umbrella problem, so this will be velocity of rain with respect to your man. Velocity of rain with respect to the man, that is equals to velocity of your rain minus velocity of your man. Velocity of rain minus of your velocity of your man. That means here the reference is right now man. I can say this fellow is your reference. See, this fellow is your reference. So what is the trick right now here is, I am writing the trick right now, see here. So a small trick I am trying to tell you right now here. See here, stop the man and give his equal and opposite velocity to rain. So this is only the trick by which all the typical problems of rain and umbrella can be done. So what is our trick right now? Stop the man and give his equal and opposite velocity to the rain. Give his equal and opposite velocity to the rain particulation. Now see, for example, I am taking a situation right now. Say for example, this is a ground and which a person is been standing right now here. Say for example, I am taking right now the situation right now. A man is standing on your ground and the rain is been falling in the vertically upward direction. Like say for example, this is the velocity of the rain which is been falling in the downward direction. Man is initially at the rest. This is the velocity of your rain in the downward direction, and velocity of the man is equals to 0. That means when the man is on a ground and he is in the rest position, for him it is appearing as if the rain is been falling vertically in the downward direction. Now see, if I say that if man starts moving with a certain velocity in the front direction, then what will be the velocity with which it will be hitting him, or what will the angle at which he should be holding an umbrella so that he can avoid the rain falling on him. So right now if I am saying a situation right now, say for example, so the same situation I am writing right now here in the condition. Say for example, this is your man and this man started moving in the positive x direction with a velocity of your v, isn't it? Now here this is the rain which is been falling in the downward direction. So this is the velocity of your rain, that is nothing but of your, we are in the downward direction right now. So previously the velocity of the man was how much for me? 0. Now the velocity of man started moving with a certain velocity, that I am taking it as of your v, and the rain is been falling in the downward direction. So how do you write from the given condition right now? What is our stop? Stop the man. Who is our reference right now? Man. Stop the man, give his equal and opposite velocity to the rain particulation. See here, if I am taking this diagram right now for this situation, see here right now for this one. So I am stopping the man, I am giving its equal and opposite velocity to the rain. So that means rain is having one velocity in which direction beta? Downward direction. So this is the velocity of your rain. I am stopping the man, giving his equal and opposite velocity to the rain. That means this is the velocity of your man for this one. That means rain has right now got the two velocities. One is in the downward direction, another is in the horizontal direction, negative x-axis. So resultant of this one will be this one. So this will be the velocity of rain with respect to the man. That means this is making an angle of your how much right now? Say for example, some angle of your beta. So what is the resultant beta? When the man was at the rest position, for him the rain was appearing him to fall, because we know that we cannot change the direction of your rain, isn't it? That is not in our hand, but we can increase or decrease the velocities of your man participation. When the man was standing in the rest position, for him it was appearing as if the rain is moving in the front direction, and when the man started moving in the front direction, in what direction the rain might be hitting the person right now? Now see here, what is the trick I told you? Stop the man, give his equal and opposite velocity to the rain. I have stopped the man right now. So this is the position of your man right now. Here I am writing. So here I have stopped the man or stop the person. Anything is fine for me. I'm stopping the person, giving his equal and opposite velocity to the rain. Now see, if these two are perpendicular as per the vectors, this will be the velocity of rain with respect to the man, making an angle of your beta with respect to your condition. That is nothing but of your R part. That means for him the rain is appearing as if it is been coming in this direction. Now see, for example, this is the velocity of rain. So if I am taking this one in the downward direction like this, this is the vertical component, this is the vertical component, and this is also vertical component part deflation. Now in which direction this person should hold an umbrella so that the rain may not be falling on him? That means the rain is appearing for him to be falling in this direction. So the rain is appearing for him to be falling in this direction. That means this person should hold an umbrella in this direction. This person should be holding the umbrella in this direction, making an angle of your beta with respect to the vertical. If this is beta, this angle is also right now for me your beta part affiliation. So I need to calculate that angle beta, and what is the velocity of rain with respect to the man. So here how do you calculate the velocity of rain beta? Velocity of rain with respect to the man will be equal to under root of your VR square, velocity of your rain, that is nothing but VR square, plus of your VM square. That will give me the velocity of rain with respect to the man. And how do you calculate the velocity of this one beta? Tan beta is equals to right now for the given condition right now. So if I am taking this one, this is an horizontal component right now. So this is an horizontal component, and this is your vertical component right now for the given condition. That is nothing but of your vertical component by your horizontal component. So I can use the relation right now from this one. Tan beta is equals to your vertical component by your horizontal component. That will give me the velocity. That will give me the angle made by the given condition. So velocity of rain with respect to man is equal to under root of VR square plus VM square, and tan beta is equals to your vertical component by your horizontal component. Vertical component by your horizontal component. This is the condition when the man was moving in the front direction. In the same way, if you say that, sir, what happens if a man is moving in negative x-axis, in what direction he should be holding the umbrella? So make a diagram even for this given condition. Say for example, if I am coming somewhere here right now in this given situation, isn't it? Now if the man is moving in the negative direction, that is nothing but here right now if I am drawing. So this is your position of your man right now. This man is moving in this direction. This is the velocity of man, that is nothing but equal to your V. And the rain has been appearing to be him falling at a certain velocity, that is nothing but of your VR. So now if the man is moving in negative x-axis part deflation, in that case what should be the direction of your umbrella he should be holding so that he may avoid the rain falling on him for the given condition? Again same trick for this one right now. So what is the given condition I am writing right now for this one also? You see, I am writing right now somewhere here, stop the man, I am stopping the man, I am stopping this fellow here right now. So velocity of the man is equals to your 0. So write the condition right now, stop the man and give his equal and opposite velocity to the rain. That means rain direction I can't change. So this is actual velocity of your rain right now. This man was been moving in this direction, negative x-axis. Stop the man, give his equal and opposite velocity to the rain in this direction. So this will become for me velocity of your man. That means the relative velocity of this one is in this direction. So this is the velocity of rain with respect to man. That means with the vertical it is now right now making an angle of your beta. That means for this fellow right now, if I am taking the component right now for the given condition, this is your vertical component part deflation. So this is your vertical line given condition. Now see what is the resultant in which direction the rain has been falling. For this fellow, the rain is appearing to be falling in this direction. The rain is appearing to be falling in this direction. That means this person should be holding the umbrella. This person should be holding the umbrella like this, making an angle of your beta with respect to the vertical part affiliation. This is a basic trick to do any type of your problems related to the rain and as well of your umbrella. Stop the man, give his equal and opposite velocity to the rain. So when the man was, see, same condition, because the falling of a rain is a natural thing. We can't change the direction of your rain. When the man, you might have been seen so many times, like see, when it is raining and if you are standing in the rain, isn't it? For you it is appearing as if the rain has been falling in the vertical direction. If you might have been going on your bike or maybe a scooter or maybe anything, you might have been seen sometimes only your front part of the body will be getting completely wet and back side of the body will be your dry, or sometimes only the back part of your body is completely getting wet and the front side of your body has been getting what you call the dry particulation. That situation is because you are moving with respect to your rain part. That means when you have been standing in the given condition, for you the rain was appearing to be in the rest condition in the vertical. The same person when he started moving in the positive direction, for him the rain was appearing to be coming in this direction. That means he should be holding an umbrella making an angle of a beta with respect to the vertical. Now how do you calculate the resultant velocity of this one? Vrm is equals to under root of Vr square plus of your Vm square, and angle by this made by this one is nothing but if your tan beta is equals to your vertical component by the horizontal component part of relation. So what is the vertical component in this one? Velocity of rain, and this one is nothing but velocity of man, because if this is Vm, this one is also Vm, and this one is nothing but of your Vr part of a relation. I hope you are clear with this one, isn't it? In the same way, if you may ask me, sir, what happens if this person is moving in the negative x-axis? In the third case, right, if I am taking the same situation, if the man is moving in the negative x-axis, again stop the man, give his equal and opposite velocity to the rain. Rain is no doubt moving in the downward direction. I have stopped the person, given the velocity of this person to the rain equal and opposite. This one is the negative x-axis, now opposite of that one is positive. So this will give me the resultant velocity of rain with respect to your man part of relation. That means this red line will be indicating that this is the resultant direction in which the rain is hitting the person. So he should be holding the umbrella making an angle beta with respect to the vertical. That angle I can calculate again by the same formula. So velocity of rain with respect to your man, velocity of rain with respect to man is equals to under root of your Vx square plus of your Vy square. Again tan angle made by this one can be calculated by the formula tan beta is equals to your again vertical component of this one whatever it may be divided by your horizontal component. That will give me the resultant and angles made by the given condition. See, sometimes what happens is, now we got an angle with respect to the vertical. Sometimes he may be also asking the angle with respect to the horizontal component. If he is asking the angle with respect to horizontal, it will be simply what right now for me? This will be your 90 minus of your beta. That will give me the answer. In this given condition, this vertical angle is nothing but of a beta. If after getting the value of the beta, if he is asking in the problem, what will be the answer with respect to the horizontal component, means this angle will become for me 90 minus of a beta. So that thing should be taken care while reading the question paper, whether he is asking with respect to vertical or with respect to the horizontal component part of relation. So based on this simple trick, we will be doing all the critical type of equations related to the rain and umbrella part of relation. For today's session of a class, I have been just given you the trick. In the coming section, I will try to take some of the important and critical type of equations where the man will be increasing his speed, like say initially he is moving with 4 meter per second and he is increasing speed to a 10 meter per second, and what angle he should be holding the umbrella. That all type of equations, and an inclined plane when the person is moving up and moving down, at what angle he should be holding the umbrella. That all conditions we will be trying to do in the further session of your classes part of relation beta. Okay, so this is a today's small trick which I have been trying to tell you. Because of the time constraint, I have been stopping this lecture for a while. Then after me, the chemistry lecture will be continuing with respect to that one. So I hope you got an idea how to do the problems related to rain and umbrella. We'll try to continue the same concept of rain and umbrella in the tomorrow session of a class with the good and quality type of your questions part of relation. So I hope by the time you come to your class for the tomorrow, bring your paper with you so that, and pen along with you, so that we can do some standard and very good questions related to the rain and umbrella, like 5 or 10 best questions which you be really getting stuck in while doing your competitive examinations part of relation. On inclined plane, maybe down the inclined planes part of relation, and increasing the speed, decreasing the speed, that all cases we'll be trying to do in the tomorrow session of a class. Okay beta, so I'll be trying to take the break for certain interval of a time, and we'll try to meet you again tomorrow at the same time from 3:30 to 4:10 for the physics section. Now I do request that the chemistry lecture will be trying to continue after me, so we'll try to break for a minute, then we'll come back with your chemistry class. Thank you beta.
V3 న్యూస్ లక్ష్యం సమాజ